3.1 goes over graphing lines using a coordinate plane. Something you want to remember about a coordinate plane, you have 4 quadrants. The top right quadrant is quadrant 1, top left is quadrant 2, bottom left is quadrant 3, bottom right is quadrant 4. The 2 lines that you see, those major lines on this coordinate plane, are called your x-axis and your y-axis. Your x-axis is that horizontal axis, the one that goes side to side, and that vertical axis, the one that goes up and down, is your y-axis. Your middle point from these 2 is called your origin. It is the ordered pair 0, 0. With this, if you're starting at your origin and you're going to the right, those numbers will be positive on your x-axis. Starting at your origin and you go to the left, those numbers will be negative on your x-axis. If you start at your origin and go up, those numbers will be positive, and then if you go down on that y-axis, those numbers are negative. The first part of this just goes over graphing specific ordered pairs on the coordinate plane. So with these ordered pairs, you want to look at this like if you look at example 1, the first ordered pair that you see there is at 2, 4. That means that starting at your origin, you are going to go to the right 2 units, then up 4 units to plot that first point. So starting at your origin, we go to the right 2, up 4, we plot that first point. Next we have 4, 2. So from our origin, we're going to go to the right 4 and up 2, plot that second point. For the third point, it gives you -2, -3. So from our origin, we're going to go to the left 2 and down 3, plot that point. Next we have -1, 3. So we're going to go to the left 1 and up 3. So that'll be here. Next you have 0, -4. So from 0, we're just going to go down 4 and plot your point on that y-axis. Last point that we have is 4, -2. So we'll go to the right 4 and down 2 and plot that point. Another way of graphing ordered pairs on a coordinate plane is using a function table. If we look at example 2, it tells us to use the function table to graph the solution set to y is equal to 2x plus 3. Now with a lot of these equations that you see, they're going to be y is equal to. However, it can also be represented as f parentheses x close parentheses is equal to. That just means the function of x, which is the same exact thing as y is equal to. So with this equation, we have y is equal to 2x plus 3. We're given specific x values of -4, -3, -2, -1, 0, and 1. We're just going to be plugging these x values in and simplifying the expression to get our y value, which will then give us that ordered pair x comma y. So just plugging these values in, we're going to have 2 times -4 plus 3, 2 times -3 plus 3, 2 times -2 plus 3, 2 times -1 plus 3, 2 times 0 plus 3, and 2 times 1 plus 3. Going back to the top, that 2 times -4 is -8, plus 3 is -5. The 2 times -3 is -6, plus 3 is -3. The 2 times -2 is -4, plus 3 is -1. 2 times -1 is -2, plus 3 is +1. 2 times 0 is 0, plus 3 is 3. 2 times 1 is 2, plus 3 is 5. So this gives us the ordered pairs of -4, -5, -3, -3, -2, -1, -1, 1, 0, 3, and 1, 5. From here, we just plot these ordered pairs on our coordinate plane. So -4, -5 is going to be here. Then we have -3, -3, -2, -1, -1, 1, 0, 3, and 1, 5. So with these functions, you have certain things that are called independent variables and dependent variables. Your independent variables will always be the x value of your function. Your dependent variables will always be the y values of those functions. So whatever you get after you plug something in for that x is your dependent. Okay? If we look at example 3, we're just given y plus 2x is equal to 1, and we're asked to plot 4 points. Because this is not y is equal to, we can take this equation and solve it for y so that way we have what we're getting or what we're looking for. So we're starting with y plus 2x is equal to 1. In order to solve this for y, we would just subtract that 2x from each side to get y by itself, and we have y is equal to -2x plus 1. So this is what we're going to use in order to solve for y. So plugging these numbers in for x, the -1, the 0, the 1, and the 2, we would have y is equal to -2 times -1 plus 1, -2 times 0 plus 1, -2 times 1 plus 1, and -2 times 2 plus 1. So the -2 times the -1 is a +2, plus 1 is 3. The -2 times 0 is 0, plus 1 is 1. The -2 times 1 is -2, plus 1 is -1. Then you have the -2 times 2, which is -4, plus 1 is -3. So these are giving the ordered pairs of -1, 3, 0, 1, 1, -1, and 2, -3. So plotting these on your coordinate plane, you're going to go to the left 1, up 3, plot that -1, 3. For that 0, 1, you're just going to go up 1 on that y-axis and plot that point. The 1, -1, you're going to go to the right 1 and down 1, plot the point, and then the 2, 3, go to the right 2, down 3. Now with these, it's just asking you to plot the 4 points. It's not asking you to draw the function on the coordinate plane, which is why we're not putting lines through these points. So if it was asking you to draw the function on the coordinate plane, then you would draw the line through the points, make sure it extends the entire coordinate plane, and then put your arrow at the top and the bottom of that line. But again, this one just says plot the 4 points, so you're not doing anything else other than plotting those 4 points. So your next example, you're graphing y is equal to 2, and you're plotting at least 4 points. If y is equal to 2, then no matter where your x values are that you use, your y value is 2. So think about 4 different x values. We can do -1, 2, 0, and let's do 3. Either way, whatever your x values are, when you have y is equal to 2, the y value is going to be 2. So all of these are going to have a y of 2. So if we plot these points on your coordinate plane, that -1, 2 is here, 0, 2 is here, 2, 2, and 3, 2. This function would literally be a straight line through 2 on that y-axis. For example 5, you have x is equal to 4, and you're plotting at least 4 points. So with all of these 4 points, your x value is going to be 4. From there, just think of different y values. You can do -5, you can do 0, you can do 3, you can do 7. It does not matter. Whatever the y value is for x is equal to 4, the x value is going to be 4. So if we plot these points, the 4, -5 is here, then you have 4, 0, 4, 3, and 4, 7. So from here, you would just draw that line through these points. And then put your arrow at the top and the bottom of that line. The next part of our lesson uses intercepts in order to graph the line. So in order to find the x-intercept, you're going to plug in 0 for y and just solve for x. In order to find the y-intercept, you'll plug in 0 for x and solve for y. For example 6, we're using the intercepts to graph the line 3x minus 4y is equal to 6. So to find your x-intercept, we're going to plug in 0 for y. We're going to have y is equal to 0, so this is going to give us 3x minus 4 times 0 is equal to 6. So that 4 times 0 cancels out, so we just have 3x is equal to 6. We can divide each side by that 3, and we get that x is equal to 2. To find your y-intercept, we'll plug in 0 for x. So this is going to give us 3 times 0 minus 4y is equal to 6. So the 3 times 0 cancels out, so negative 4y is equal to 6. We divide each side by that negative 4, and we get that y is equal to negative 3 over 2, which is the same thing as y is equal to negative 1 and 1/2. Now these y-intercepts and x-intercepts are ordered pairs. So it's not just x is equal to 2, y is equal to negative 1/2, 1 and 1/2. It is the ordered pair 2, 0 for your x-intercept, and the ordered pair 0, negative 1 and 1/2 for your y-intercept. So these, if you're just asked for your x or your y-intercept, you have to give those ordered pairs. To plot these points, that 2, 0 is going to be here, and that 0, negative 1 and 1/2 is going to be here. So to plot this or draw this line, we're just going to draw our line through these points, putting arrows at the top and bottom of that line, and then you're done. Your last example tells us that a store manager is ordering shirts at $20 each and jackets at $30 each. So this can be represented as 20 times the amount of shirts and 30 at the amount of jackets, so that's J. The total cost of the order is $1,200, so that's 20S plus 30J is equal to 1,200. We're writing an equation for the total cost and graphing it. We don't have to graph this one, but if we are solving it so that way she orders the 15 shirts, so this is going to just become 20 times 15 plus 30J is equal to 1,200. We're going to multiply the 20 and the 15 to get 300 plus 30J is equal to 1,200. We subtract the 300 from each side, and we get that 30J is equal to 900. From there, we just divide each side by that 30. Those cancel, so J is equal to, these can cancel, 3 goes into 90, 30 times, so 30 jackets.